Hello ma'am, this is the part 2 of the video which contains a demo about how to create a logic circuit IC using NAND gate. And to start things off, we will add a circuit and will be named as IC7400. Now we will double click the IC7400 and we'll work on the sub circuit, and then uh, we'll click gates, and on the NAND gate we'll be placing it here, and then since we have only two inputs, the inputs will be 2. And after changing the number of inputs, we will add some input pin, and then we will rotate it south. We will be copying and place it here, and then we will be placing it here. Then after that, if we have an input, we also have an output, and this circle pin will serve as our output. And then we will be rotating it here south, placing it here. Then we connect the dots. And as you can see, we have an input of 1 instead of 0. In the previous circuit, if we inputted both 0, the output will be also 0. But in this case, it will be 1. Why? Because it is a NAND gate. And the NAND gate is the opposite of the AND gate, because the NAND gate is uh, the AND gate, I mean, is being negated, hence the NAND gate. And if we try to change the input to both 1, the output will be 0. And to prove what I am saying, we can analyze the circuit. And to analyze the circuit, we can highlight this circuit and then right click the IC7400 and analyze the circuit. Just a moment, I will show you the uh, combinational analysis. There you go. This sign you can see there in the left middle part is the negating sign, which negates the add table. And then this is the input, the output, and the table. And as you can see here in the table, if you have an input of both 1, the output will be 0. Otherwise, the output will be 1. And that is the truth table for the NAND, NAND gate. And then proceeding to the IC. There we go. Copying it and pasting it. At this point, we will be completing the inner part of the IC. We will be using NAND gate, NAND, and the number of inputs will be changed to 2 again, placing some uh, input pins, rotating it to north, and the output pin, which will also be rotated to north. And there you go. We will be connecting some dots now. And there you have it. We'll be replicating it. We'll be placing it here. We will be, like in the previous video, we will be uh, imitating the truth table by putting the inputs in the truth table here in the circuit. And by doing that, in the left side again, the A or the X, the sequence will be like this: 1, 1, and then 0. Oh, I mean 1, 1, 0, 0. Yes, it's right. And then the for the right side, which is the Y and the B, has a sequence like this: 1 0 1 0, and there you have it. And for go to the next, we will be labeling it to remind us that we only have uh, 1 2 3 6 12 pins instead of, we only have 12 pins instead of 14 because the ground pin here in the lower right side is not present, and the upper left, I mean, for the VCC is not also present because the app itself can run without the VCC and the ground. And we can label this by with one and then south, south, 3 south, 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 6 south. Reminder, the seventh pin is not here since it is the ground. It is for the ground, I mean. Then this will be the eighth pin since the seventh is not present. And this will be the ninth pin. Ninth pin. 9. North. And this will be the excuse me, 10 pin. We place here north. 11 north. 12 north. Oh, north. 13 north. And there you have it. We have completed the inner IC. And for the external, which is this one, this is the uh, this is the overlook of the IC. To not confuse ourselves, I will be labeling it as IC7400. I label it again so we have a distinction between the previous video, which is the IC7408, and this IC, which is the IC7400. There you go. And to prove that the IC is working, we'll be putting some pins here and facing it north. Facing it north. Not the label, facing north. Then I will be adjusting the output pin so it will be not crowded. There you go. And to prove that the IC is functioning well, we will be connecting the dots. Connect the dots, connect the dots. And there you have it. And it satisfies again the truth table of the NAND gate. Since the AND gate will have an input, I mean, it will have an output of 1 for the AND gate if it has both 1 on the inputs. Otherwise, it will be 0. On the other hand, in this circuit, if we inputted both 1 in the input, the output will be 0. And that ends the demo for the NAND gate.